Hey guys, Ms. Smith here. I am going to go through the notes for section 3.6, and it's called Piecewise Linear Functions. That word looks kind of weird. It probably sounds kind of weird too. But basically all a piecewise function is, it's a function that has more than one piece. So I'm just going to use that very, very basic definition. Keep it simple, and we'll kind of show you what it looks like and how to evaluate it. So a function that has more than one piece. Okay. So if we look, this first one, you guys aren't going to have to graph these at all. But we do want to show you kind of what it looks like when you do graph them. So usually when we graph a linear equation, it's obviously just a line. So it can be increasing or decreasing, horizontal or vertical. But with a piecewise function, you have two pieces that will be graphed. So how we deal with this is what it looks like over here. This is the piecewise function. And it says f of x, and you guys can see that they have this bracket. And we have x minus 3 is one of the pieces, and then 1/2 x plus 4 is the other pieces. Over here, they tell us when to use what piece. So this, if this is not familiar to you, it's basically saying when x is greater than or equal to -3 and less than 0, we use this piece. And when x is less than or equal to 4 and greater than or equal to 0, we use this piece. So if we were going to fill in this table, in usual life, we just have one thing to plug into. So we take the x value, we'd plug it into our function, we'd do the math, and we'd get an output value. But we have to pay a little bit more attention when we do it this way. So -3, so it says x is greater than or equal to -3. So -3, we would use the top piece. So if I'm going to show my work here, f of -3, we're going to use this top piece. So we plug in -3 for x minus 3, which is going to be -6. Okay. -2 also falls into this category because -2 is greater than -3, but still less than 0. So I'm kind of draw an arrow. So f of -2 is -2 minus 3, which is -5. All right, -1, we're still falling in this interval. So -1 is also greater than -3 and less than 0. So f of -1 is -1 minus 3, or -4. And then 0, this is where you got to be careful. I know we see a 0 here, but it says x is less than 0. It doesn't have the extra equal to part. So we are now going to plug 0 into this piece because this is where it says x is greater than or equal to 0. All right, so that's the difference with a piecewise function. We have to make sure we plug our input value into the correct piece based on the domain that they're talking about. Okay, so 0 will get plugged in here. So I'm actually going to use a different color to show that. So if we go here, f of 0 would be 1/2 times 0 plus 4, which is just 4. And then all of these, 1, 2, 3, and 4, they are all greater than 0 or equal to 4. So the rest of these values we will plug into the bottom piece. Okay, so this one, if we take f of 1, we get 1/2 times 1 plus 4, which is just going to be 4.5, and I'm going to use a decimal there. Running out of room here. So the rest of these, hopefully you can kind of, I'll go over here. F of 2 is going to be 1/2 times 2 plus 4. So half of 2 is 1, 1 plus 4 is 5. And then the rest of these, I'm just going to kind of talk through it in our head. So if we plug in 3 here, half of 3 is 1.5. 1.5 plus 4 is 5.5. Hopefully you're getting the hang of it. And then when we plug in 4 here, half of 4 is 2, and 2 plus 4 is 6. Okay, so when we graph this, the blue coordinates will show up as one piece on this graph, and the green coordinates will show up as another piece on this graph. So it's not one continuous function. All right, so when we do this, -3, -6, so 1, 2, 3 to the left, and then down 1, 2, 3, 4, 5, 6. And we have -2, -5, and -1, -4. And then if we, let me draw that real quick. There's a little bit of a hard part about this. We'll come back to it at the end here. But our green piece, which is graphing the numbers we plugged into the bottom piece, is 0, 4. So 1, 2, 3, 4. 1, 4.5. 2, 5. 3, 5.5. And 4, 6. So here's the deal. We actually would draw this blue piece all the way up to 0, but we would have to put an open circle there, because in order to state that this piecewise function is a function, remember it has to pass the vertical line test. So if this vertical line test goes through these 2 points, both of them cannot be colored in, because then 2 points would go through the vertical line, therefore it wouldn't be a function. So that's why this has to be an open circle. If what I'm talking about is not making any sense at all to you, don't stress about it. You guys won't have to do the graphs. But the idea in going through this was just to show you that when we have a piecewise function, so it's made up of more than one piece. So in this one, we have 2 pieces. And this tells us when we plug certain x values in where. If we were to graph it, we can see those 2 different pieces, okay? The only thing you're going to have to do with piecewise functions, after we look at this, is on this next page, and this is what you guys' homework will be like. The only thing you guys are going to have to do is, given a piecewise function, you're just going to have to evaluate certain values, input values, okay? So this piecewise function says g of x equals, this is 5 minus x. It's not very clear, so x less than 2. And again, use colors here. And then the second piece, hopefully you can see that says 1/2 x plus 2, and x is greater than or equal to 2. All right, so we're just going to go through a couple of examples. And again, this is a little bit easier than the first one we just went through, because either x is less than 2 or x is greater than or equal to 2. So it's a little bit easier to figure out which one to plug it into. So just like we did before when we evaluated functions, we look at the input value, that's the one in parentheses. So this is our x value. So an x value of 1. So this is saying x equals 1. So we have to see where is the value of 1 fall into? Is 1 less than 2, or is 1 greater than or equal to 2? And I think you guys would agree with me that 1 is less than 2. So that tells me we plug 1 into the top piece. Okay, so g of 1 would be, we take the top piece, it says 5 minus x. So our input value goes in for x, which is 1, and 5 minus x, or 5 minus 1 is 4. So that's done. Okay. The second one says g of 8. If you can't see that, let me rewrite it. That's what it's asking. And 8, so this is x equals 8. So an x value or an input value of 8 is clearly greater than 2. So we use the bottom piece of this function. So g of 8 equals 1/2 times 8 plus 2. Again, if you get concerned about this fraction, first of all, you can type it into a calculator, but just understand 1/2 is the same thing as dividing by 2. Or if you ask yourself, what's half of 8? Half of 8 is 4 plus 2, so we get 6. Okay, so these 2 were pretty obvious because 1 was very much less than 2, so we plugged it in here. 5 minus 1 was 4. 8 was very obvious. 8 is greater than 2, so we plugged it in here. Half of 8 was 4, plus 2 was 6. this is the one that sometimes causes problems because if I rewrite it, it has an input value, an x value of 2. Well, we see a 2 here and here. So we have to be really careful and we have to look for where is x actually equal to 2. And we see that that equal sign is on the bottom part, on the bottom piece. This says x has to be less than 2. This is x is greater than or equal to 2. So this is going to get plugged into the bottom piece. So g of 2 will be half of 2 plus 2. Again, half of 2 or 2 divided by 2 is 1. Plus 2 is 3. And then the last one says g of -4. So x equals -4. Well, -4 is less than 2. So we'll plug it into the top part. Again, just be careful here. This is why I use parentheses a lot of the time when I'm plugging stuff in. So g of -4 will be 5 minus -4. So we got to remember that when we subtract a negative sign, it really becomes 5 plus 4, which is 9. All right, so this is the only process you guys will have to do in your homework. Okay, so we're going to try one more of those real quick together, and then hopefully that'll kind of help make sense of all of this stuff. So again, here's our second piecewise function. It's different. It says -2x plus 10, and it says x greater than or equal to 0. And then the bottom piece, just highlighting it here, is 5x minus 1 and x greater than 0. All right, so 0 is kind of our determining factor here. So if we look at this first one, f of -5, our input value is -5. Well, -5 is less than 0. So we'll plug it into the top piece. So our x value is -5. So we have f of -5 is going to be equal to, the top piece says -2 times our input value plus 10. Our input value is -5. So be careful here. Negative times a negative is a positive, and 10 plus 10 is 20. Okay, second one says f of 3. If you can't see that, I'll rewrite it. So 3 is greater than 0. So it's obvious that it goes into the bottom piece. So x equals 3. So f of 3, the bottom piece says 5 times our input value minus 1. So there's 3. So this is 15 minus 1, which is 14. C says f of 7. Again, 7 is greater than 0, so we plug it, x is 7, we plug it back into the bottom piece. So we get 5 times 7 minus 1, which is 35 minus 1, or 34. And the last one is the one, again, where you got to just pay attention to it real quick, because it says f of 0, and I know we see 0 in both of these, but only one of them says that x can be equal to 0. And that's the top one, because we see this extra sign with it. All right, so f of 0. So f of 0 will be the top one. So we have -2 times x plus 10. Oops. So we plug in 0 there. This is 0 plus 10, which is just 10. Okay, so in general, that's the process that you guys will have to do in your homework. Hopefully that made sense. If you do have any questions, you can ask your teacher in class.